So I've got a sort of long presentation because it's divided into two things. It's like a little bit of theory. I'm going to fly through it. There's so much content available about Kubernetes out there. So you can go online, you can find that out. But I'm also going to be doing a little bit of a demo of what I used to learn Kubernetes and so forth. But anyway, my name is Rowan. For those of you who didn't see that, and I work at Takealot in the logistics division. So we make sure that your parcel arrives at your house on time, and that when you want to send it back, it gets back on time and so forth. Yeah, so I'm not a DevOps engineer, just so that you know. So there might be a lot of sort of missing spots on what I present, but you can learn that in the future, or maybe there's someone that's an expert here that can sort of fill out the missing links. Thank you again for listening to me, by the way. Really appreciate it. So in this little talk, I'll be talking about what is images, what are containers, and what is Docker very quickly, because I'm aware that there might be someone here that doesn't know like what that is at all. What is Kubernetes? And then after that, we'll go into some Kubernetes concepts, and then we'll look at spinning up an application for you in a cluster that I've spun up. So I spun up the cluster in GCP just like an hour before the talk, just to make sure that there's no sort of issues that's going to happen with that. But it takes like 1 minute to do that. It's not really very difficult. Cool. Okay, so Alex asked me not to do just like theory, to actually have something that's practically Kubernetes and people can see it, and it's maybe fun. I don't know if it's fun, but I started working on a hobby project ages ago. It started off with a simple church member database, and it's this little module over here called Church People, and it was to store like sort of be a church member database. However, I got scared of Poppy and people's private information, and so I abandoned that project. But I still have a working API there. And then I started working sort of on an auth module, and I thought, okay, cool. People are going to need to log into this thing. Let me focus on that just to learn maybe JWT auth, and I wanted to add like OAuth, like logging with Facebook, logging with Gmail, just to to learn more about authentication, authorization, and stuff. But I never got that far because you get bored with these hobby projects. But there is JWT auth with permissions and so forth. And then also like I'm part of a worship team, and so we have like sheet music and songs and a database. And at that time I wanted to learn Scala because we use Scala at Declarative. So I built this little songs module, and then I wanted an endpoint that would basically merge PDF, piano music, guitar music, lyrics into a book that the musicians could use. And it was taking me like 3 days to implement in Scala, and then Python took a few hours and it was done. And then added module by module, and at the end of the day I had this big little mess of lots of services, and it's one of the most over-engineered hobby projects that you'd ever see. But how it's running now, like sort of in the production environment that I actually use, is all as Docker containers on one DigitalOcean VM. And it's very tricky and messy to work with. I use Docker Compose, and I go into this box and spin up things and pull the images and respin it, but that's not really great to work that way. But anyway, before I go any further, someone might ask, what is a container? What is Docker? And there's this little meme, and the little dev goes to the big dev and says, this thing, I don't know why there's this production bug. It works on my machine. And then the guy, says sarcastically, we'll ship your machine then. And basically that's how Docker's born. Docker, what is a container? A container is a lightweight standalone executable package of software that includes everything, your application code, the runtime, the system tools, the libraries, and so forth. It shares the machine's operating system that it runs on. And so, with VMs over here, you have your operating system and then the VM running on it, and the VM will have its own operating system. Whereas with containers, containers all share the host operating system, and the runtime engine provides the libraries to it. But then the nice thing also is that the application running in the container is very isolated from each other. I can't spend too much time on the theory, so please forgive me if I'm going too quickly here. Containers are great. There's a lot of great reasons here of why containers are great, and you know that, and that's why you're on this call. So I'm not going to tell you, you can read that up online. Okay, Docker images and containers. So Docker itself is a container platform or runtime engine. It is not the only container platform that you get. You get others like CRI-O, Containerd, and Fracty, but Docker is the most popular one. Container, now I'm interchangeably sometimes using the word image and container, but an image is what you build from your software and you push that up to like an image repository, for example. When you run that image, it instantiates and you call that a container. That's what's running on your machine, in your cluster. That's what a container is. Now, in your code, you'll have a thing called a Docker file, right, in your repository. So say, for example, if you go to the source, wrong one, the source code, in here you'll see that there's a Docker file in the main directory. This Docker file can be anywhere, but it's just nice to have it in your source code. And in this Docker file will be the instructions on how your image is built. So this is a multi-stage Docker file. It will build a container that then builds your software into a jar, and ultimately this is what then runs in this container, this command over here, and that's the spec of the image basically. I've got the same file there. Now, if you wanted to build this on your machine, this is the command you're on. Very simple, docker build, dot means the current directory, minus T just gives the image this name, church people. So if you run this, at the end of the day, you'll have an image on your machine with this name. That's the repository and that's the name of the image. Then what you can do, if you really want to, you can push this up to an image repository, or you don't have to. You can basically just run it on your machine with this command, and this will basically take that image and then create a container running. And this is not going to work. You need to expose it in ports and stuff. It's very simple. It's just a few things that's maybe missing there. But then you'll be able to hit that service on your local machine or wherever you're running it. Okay. Now, if you saw that picture that I showed you, there's a lot of services, right? And it gets, imagine you have to run Docker build and Docker run, and for all of those 12 services. Now, in the real production environment, that take a lot. There's hundreds of, or maybe even thousands of microservices. Docker Compose doesn't solve that problem, but what it does, you can have a whole host of spec container, I'm not sure what to call this, elements in the Docker Compose file. And when you run Docker Compose up, it will spin up a MySQL container and a church people, in this scenario, church people container. And you can have all of it defined in this one file, so that when you run Docker Compose up, it will then spin up all of these with the configuration that's listed here. If you have any questions, please stop me. But again, also bear in mind that I've got limited time. So right, I told you what Docker is. I told you what Docker Compose is. Docker Compose, the problem with it is that when you spin this up, that all of those containers or those applications are going to be spun up on the same machine. And that's where Docker Swarm comes in, because what if you have 3 machines and you want to spread the load across them? Docker Swarm will be a container orchestration tool that will allow you to spread these containers across different nodes and allow them to talk to each other. But that's Docker Swarm. Kubernetes is doing the same thing, but in a much better way. That's much better than Docker Swarm. So I say you should use that. And that brings me to the topic of Kubernetes. Okay, Kubernetes, that's a very complex sounding word. Some people call it Kates because there's 8 letters between K and S. Kubernetes is a portable, extensible, and open source platform for managing containerized workloads. It's a mouthful. Just emphasis on an open source platform. Someone asked me what's the difference between ECS in AWS, which is the Elastic Cloud service, I guess. The thing with ECS is that it's AWS technology. Kubernetes is open source. So when you build config files, they're called manifest files in Kubernetes, they can run on EKS in AWS. They can run in GKE in Google, in Azure, AKS, whatever it's called, and in DigitalOcean's Kubernetes, and OpenShift, and all of these Kubernetes engines. The same configuration files are going to work in all of these things, and that's also the power of Kubernetes. And even if you want to run it locally, you can do it with minikube for just testing and dev. Okay, Kubernetes takes care of a lot of things: scaling, failover, communication between services, and so forth. And I'll show you how this is done a little bit later. Okay, so again, what is Kubernetes? Imagine a soccer team, and you can imagine my 11-year-old soccer team. Well, they're a little bit better now, but back in the day, you threw a ball on the field, and all of those guys would run everywhere. No one would know what they're doing. No one would talk to each other. And then, a coach comes along, and he puts some players in the attack, put some players in the mid, some players in the defense, and a goalkeeper, and they learn their positions. And basically, Kubernetes is that, right? For pods, it's telling this pod go into that node, this pod go into the other node, and they're learning to talk to one another. And at the end of the day, that's really a winning formula. And so, the best team in the world, Liverpool, I have to just put that in there. Cool. So again, this is all our services, and we're going to use Kubernetes to spin this up. And we're not going to worry about which node this thing's going to go on. We're not going to worry about, how they talk to each other, like based on IP addresses and all of those things, because Kubernetes is going to do that. And we're not going to worry about scaling as well, because, we're going to just write some config to do it for us. I do have some more things on Kubernetes. So just, you can imagine this, you don't necessarily spec and I'm just using normal, like not Kubernetes language, but which app a node will go onto. Kubernetes will decide that for you, but you can, with some config, say, okay, you prefer this node, and you can actually tell it to go on a particular node if you wanted to, but normally you don't. So maybe, this will be a scenario where you have like these 3 applications on the one node, these 3 applications on the node B, and these applications on node C. But you could even have an application like, the church auth module running on this node and running on this node in different pods. But I'll explain what a pod is later. So a cluster, with Kubernetes, you'll have a master node and you'll have worker nodes. Now your worker nodes is where your pods get scheduled onto, and your master node is the one that's telling it where to go to. You don't actually have to even know about the master node or understand how it's doing this, right? Abstract it away when you're learning Kubernetes. When you instantiate the cluster in AWS, like the EKS cluster, or in GCP, that master node is what gets created behind the scenes. You just will assign a node pool in GCP, for example, of worker nodes to it. And you can assign more than one node pool, obviously, but anyway, we'll get there. A pod is the basic execution unit in Kubernetes. This is what, how your application is deployed as a pod. Now, for example, a pod is not like a container that I mentioned earlier. Is it like your running application? You can have, one or more pods defined, one or more containers defined in a pod. But you want, for example, you could just say, for example, have the church people container running here and its database in the same pod. But you won't do that, because the whole thing about Kubernetes is you want things to be able to scale independently, and you want to separate logical concerns. So the database should be in a different pod, and the application in its own pod, and the gateway in its own pod, and so forth. But where you will have a container, in the same pod is maybe like logging. Logging will, like a scraper, log scraper. And so, there's like a need, a tight coupling between those containers, and things like Prometheus and other Istio and all of those sort of things, that there's metrics and whatever. Sometimes you'll have a sidecar container in a pod. That's what they call it. Like a log scraper and a metrics scraper, whatever, would come as a sidecar container, but you will spec it to do that. Okay, this is just an example of 2 worker nodes with some pods, and then you can see in each pod there's 3 containers. But normally, in a hobby thing now, I'm going to put one container in each pod, right? So just quickly, minikube. I'm not going to go into this. minikube is basically a VM with Kubernetes in, and you can easily install minikube, with, in MacBook, you'll say brew install minikube, and then this is how you'll use it. It will spin up a VM with Kubernetes in, and then you can run your kubectl commands in there and spin up whatever you want. It's very cool. This is a manifest file. I'll show you some actual manifest files later on, but this is a pod manifest file. You can see the kind here, it says pod. So when you run this by saying kubectl apply if my app, it will instantiate a pod according to this specification. Here's the image, BusyBox. Sorry. Okay, now remember I mentioned that pods need to, or I don't know if I mentioned, but pods need to talk to one another. And normally, like with applications, when you want to talk with to another application, you will take its IP address and you will send a message to that IP address. But in the case of pods, pods are not permanent things. They're supposed to be able to be killed, brought up, as scale demands, or if a node falls over, Kubernetes must be able to take a pod and, bring it up on a new node. It will be a totally different IP addressing. So services are what abstracts that away so that Kubernetes will allow you to talk to other pods through its service, which you define again with the manifest file like this. So here you can see this kind as a service, and then you're saying basically, it will be available on port 80 with the selector my app, and because of the name my app service here, when you want to talk to it, you will use this name. Cool. You get different types of services. You get like node port, which I won't go into. Cluster IP is what's used for intra-process communication. So in that architecture diagram that I showed you with all the services, all of the services that I don't want to be exposed to the internet, everything besides the gateway, basically. Well, not even the gateway, but everything has cluster IP because you reach the application through the ingress and not through app. But you can make it a load balancer, and then the load balancer can be internal, external, and if it's external, then you will get an IP address, and you'll be able to access that outside of the cluster. I mean, outside of from the internet. Cool. Kubernetes is declarative, so you don't have to ever run a series of commands to tell Kubernetes what to do. You say, for example, you want to spin up 3 pods of Nginx. So you will just say 3 in the file under next to replica, and you will run that command. If you run it again, you're just telling it, okay, you want whatever you've changed in there. And Kubernetes will make sure that the system is running in the state that you've told it, the desired state that you want. Now, in the case of here, the manifest file would have had 3 replicas, and what could happen is, say, for example, this node falls over, like this, the actual virtual server falls over, then what Kubernetes will do without you even telling it is it will try and move that pod over to the next node. Sometimes it won't be able to do that, but in most cases it would, and it will move it over for you so that it ensures that the thing is running in the state that you desire. Cool. Now, when you're actually spinning up application, you won't use the kind pod, you'll use deployment. And the deployment is like a layer above pods. Here you can specify how much replicas you want. So if you run this, it will create, a deployment of church people with 2 pods running. And just to go quickly, it will tell you, it will use the church source, church people. When you spin up a cluster, it automatically will know to pull this from Docker Hub. But you can obviously tell it to use other container registries as well. But it will not find it in the other registries, and therefore will use Docker Hub, and it will work. The name that it will give for this container would be church people. And the resource limits, this is interesting. I can't go into too much detail here, but basically the limit is a hard limit. Your application will never be able to use more than 400 megs. So it will fall over at that point. If you have a CPU limit, again, it will force the CPU to be limited to whatever you spec. Request is different. So in this case, it's 100 M, which means 1/10 of a vCPU. 1000 M is 1. And so if you tell it request 100, you can also put a memory request in here and say you put the memory request as 200. It just helps the scheduler to know where to put the pod on. So if there's 200 megs, say you've requested 200 megs, and there's 100 megs available, and this is not a realistic scenario, but it is 100 megs on two nodes, but there's 400 megs on the third node. Because you requested 200, it will now, okay, put it onto the third node. That's what requests are for. And what it also tells Kubernetes like how much resources required. So it will tell you this cluster is under spec based on all the requests. So if you requested like 300 pods and they're all requesting a tenth of a vCPU, you're going to be in trouble if you only have like one or two nodes. Cool. Let's get into the demo. So for the demo, I'm going to spin up a MySQL database as a pod. I'm going to spin up the people module, and I'm going to spin up an auth server because you need to be able to log on, and then the gateway because the website needs to talk to these services, and that basically provides a single point of entry. And then I'll spin up the front end so that we can see it to the website. Okay, let's start. Any questions before? No. Okay, so just to quickly show you, I've got a directory here, and normally you'll have your Kubernetes manifest or Helm charts, but I'll get into Helm charts later. Normally you'll have them in the repo that you're working with, although that's like up to debate. It depends on how you like to work. So I'll go into church. Actually, before I run the church people module, it's probably good that I have a database. So here's a persistent volume claim because the database can need space. So this will basically reserve 5 gigs of hard drive space on a node. And this is not like maybe how you do something in production because it will tie your pod onto a particular node and those sort of things. But let me claim this one. I'm not going to go into too much detail about what this does. Let me just get in, make sure I'm in the right place. Can you all see what's happening here?
Yeah, we can.
Yes, yes, we can.
I didn't even show you that there's nothing on the spot, but I'll do it on this cluster. I'll do it once this. Okay, cool. So it says the volume has been created. So I'm going to say get pods. You can see there's no resource found. So I'm not going to be fooling you. This doesn't work. It doesn't work, but it will work, I'm sure. Okay. The next thing I'm going to do is spin up the actual deployment. So if you go in here, you'll see there's one replica. It's going to use the MySQL image. It's going to be MySQL version 5.7. So that's the deployment. Okay, let's see what's happening with the pod. And there's nice graphical views as well, which I'll show you later. So you can see it's in status container creating. If there's a bug or something, often this thing will fail to start. Now my service is going to need to be able to talk to this database. So who can tell me what I need? I've mentioned it in the presentation.
A service.
Okay. Quickly, anyone's going to us? Yes.
A gateway.
Service.
Oh, service. Okay.
Yeah. So the gateway isn't a Kubernetes concept. Sorry, I wasn't very clear. That's a Spring Java application, but maybe what you were talking about is a load balancer. That's to make it available outside of your cluster. But if you want pods to be able to talk to one another, then you need a Kubernetes service. So if you go in here, you'll see this service is the name is MySQL. This is an annotation, a Google annotation, which is things that each provider can use how they want to. Internal, and the type is cluster IP because we only wanted to the database to be available inside the cluster. So I've applied this the service now. Cool.
Yes, services in English are usually a big topic with Kubernetes.
So I'll open up
it's an interesting.
Hello? What's this? Okay, I couldn't really hear what you're saying. So anyway, I've spun up that, I applied that service. So if I go to like, okay, quickly, I just opened a, oh, my internet is going. Can everyone hear me?
Yeah,
Yeah.
can hear
Yeah,
you.
we can hear you.
Hello?
Yes,
we can
yes,
hear you.
yes, we
Yeah.
can hear you. Yeah.
Oh, okay, cool. Okay, thank you guys. So I opened up an application called Lens, but Lens is just a nice viewer for what we're doing. So instead of me like running kubectl get pods, I just go here and say pods. Instead of me running kubectl get services to see the services, I'll go here and then it will show me, okay, there's that service that I spun up, and there's the internal IP address which we never use, and it's not available outside. Okay. The next thing I'm going to spin up is the church people application. I just want to show you again this that people module. So I've spun up this, I've created a service, and now I'm going to spin up this one. Okay. Quickly, just to show you the deployment. Yeah, it's going to now spin up 2 pods because it says 2, and it's going to provide these environment variables, and it's going to use this image, church people, and it's going to limit it to 400 megs of memory each pod. It's quite a lot, but Java's can be hungry, and then request 100, a tenth of each virtual CPU, which you don't even have to. When you start learning, you don't even have to put this in. It's just there to show you that that's possible. Okay, spinning up the deployment. It normally doesn't take this long. I think my internet is slow or something. And you guys, okay? Let me just show you on here. There should be 2 pods now spinning up. Oh, I'm gonna just turn off my camera. Okay, so you can see there now it's spinning up the two pods for that church people module, right? The next one is let's spin up the auth module. CD. Oh, well, let's just check that this thing's spun up properly. Okay, they're all running fine. So you just have to trust me. It says it's running, so it's running. You can check the logs. Normally you have like a Kibana server, which with something that scrapes all the logs. And but because this is a basic demo, you just can request logs like this. kubectl logs, and then just specify like the pod name, and then it will pull the logs. Of all the times that your internet gives issues, and now, can you guys hear me?
Yeah.
Perfectly.
Yeah.
Yes.
Yes, 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 we can hear you.
Okay, so there's the logs. Okay, I think there's a massive delay also, but here's the logs, and you can see the service started in 22 seconds. Okay, don't forget, I must spin up. I must apply the service as well, so that other applications can access that pod. Oh, I'm getting serious network issues over here. Okay, the service has been created. So now I'm just Getting the services to show you that it has been created. You can see church people now the service. So let me go back to the church. Like I said, the next one should be the auth server. Sorry, just to show you what's in here, is this deployment and the service. So yeah, again, 2 replicas, very much the same thing. It's going to spin up to, hey, I think my internet's coming back now. Or maybe not. Okay, yeah, so now it's creating these 2. Let me create the service. You can see the 2 auth pods over here. Apply -F. Okay, so that's gonna now create a service so that other services can talk to the auth. Also, you can see the auth service is there now. If you look in here, you can see it's come up here as well. Just a no. Cool. Also nothing external. Okay. Now the gate. So let me just show you the architecture. The little diagram again. Right. So we spun up the MySQL database and the service. It's the people module, auth module, and the services. And now, in order for the website to be able to connect to these services, we're going to spin this up, not like in this configuration. We're going to just make this one an external load balancer. So I'll go in there and I'll show you. This is the deployment. Oh, sorry. I'm getting ahead of myself. This is just another service. Same as everything else. Cool. And then if you look at this one, this is the service is the load balancer. So I've said type external and type load balancer. So when I run this, see now group CTL get services. Okay, now you can see this church gateway service is here. That's type load balancer. So if I were to go into the Google console now, and you'll see, and outside of the Kubernetes engine side of things, you will, and into the the load balancer section, you'll see that the load balancer exists there. It takes a while to get an external IP address. So I need to now just spin up the front end, but I need to provide an IP address. So is there any questions that you want to ask while I wait? This will be in maybe 1 or 2 minutes. Have I lost everyone?
No.
Okay. There's the IP address. Cool. So I'm going to plug this in here.
Still hear you.
Okay. Now, this is just going to tell the front end, because the front end is going to be served to your browser. So I need to set it the IP address and obviously HTTP, because that's something that you get into. Okay. So I'm going to apply this, go into the front end folder. And again, this folder structure has nothing to do with Kubernetes. You can just provide it YAML files in any directory and to work. This is just how I split this up. Okay. Sorry. Oops. No one warned me. Okay, so I'm going to apply the deployment so that this will bring up one front-end pod and then a service. Now, this isn't the service that makes it externally accessible. That's what makes the gateway be able to eat this pod. And this is actually Nginx, based on Nginx, this image. Cool. All right, so if I show you Lens quickly, just to visualize it. We've got the people database application started. We've got the auth through the auth application or pods spun up. We've got one gateway pod, and we've got the front end and the MySQL database. We've got services. All of these services make those pods accessible, but the one is making that service, the gateway service, accessible to the internet. So I'm gonna quickly go to this thing, and this is the demo pod. So it seems to have worked. It's amazing, but it's a little bit slow. So this application, the best part of this application is the login screen. Everything else after this goes downhill. So I've signed in. So the auth server worked. Okay, I'm just using passwords, so it won't be about that. The auth server logs in. Just quickly put some data so that you know it's working. So 6 years old. Cool. So you can see that it's actually saved data to the backend. However, there's a find song thing, but that's not working because I haven't spun up that. Now, here's what I want to show you. This is very basic. This is very like a basic way of spinning up, and it's very error prone. Like there's a deployment file, there's a service file, there could be volumes, and there could be like HPA config, and you could easily forget to run one of those things. So there's another tool called Helm, right? And Helm is just like a layer on top. It's like in other words, actually, it's a good way to explain it is Helm is a package manager. So what NPM is to Node, Helm is to Kubernetes. And I'm going to spin up like the church songs application, this one over here, by using Helm. So what Helm is a tool that you install on your machine. So I've got Helm 3. And that's nice because with Helm 3, you don't have to install anything onto the cluster itself. Way back in Helm 2, you'd have to install an application called Tiller, and it was complex. But with Helm 3, you just install Helm onto your machine, and then what makes it chart is just this format, like of a templates folder, a chart.yaml, which just has the name and the version and so forth, and then the templates. Now, if you look at this template, this is the deployment, like, if you remember, I was applying deployment. This is exactly the same thing, except now, because I've picked this on top, you can now, it will now pick this name up from the chart, which is church songs. And it will pick up the resource limits from the values in the values. Now, why this is powerful is because you can actually create different values files for different environments. So you could tell Helm, okay, you want this to run a pre-prod, so then have a pre-prod values file, which will override some of the values from this values file. And then again, there's a service. Now, instead of running all things, like everything separately, what I can do is just run the Helm install. So there's a folder in here called church songs chart, and if I go like that, that you see it says it doesn't exist, and it's installing it. And I mean, you saw it's not complex things; it's just like one and two files. Let's see if it instantiated properly. We just you can see that that's creating the container, and eventually it will work. Now, the power of Helm is that you don't only create your own, your charts. You can get charts from Elasticsearch, for example. So part of what the songs need to do, you need to be able to search the lyrics, and so I use Elasticsearch for that, and to install that, I can use Helm's charts that they provide themselves. And normally you have to add a repo, but Elasticsearch repo is already in there, so you don't have to provide that. There's a basic values YAML file here, which just overrides very few settings. So now it's installing Elasticsearch, and like it would be so complex to create an Elasticsearch group of services, like three nodes. I mean, you can imagine how complex that will be if you were not using something like a Helm chart. So here you can see it's spinning up, and it will very quickly go be moving to a running state. Okay, how much time do I have left, Alex?
Okay, Rowan, I think so. We're gonna extend the event till 9:15. So we usually end it at 9 sharp. We're gonna extend it to 9:15 because this is really good, and internet has been getting in the way, and I think we need to see this through. So just go ahead and do your thing, Rowan. This is good stuff.
Cool. So Kubernetes has another type of specification file called the cron job. If you see, can you still see my screen? Yeah. So yeah, often with stuff that you need to do is like you need it to run at a specific time on the cron job, and normally you'll go into a server, you type cron tab -e, and then you will give it the schedule, and you'll tell it what command to run. But Kubernetes has it built in, and here you specify the schedule. I'm gonna just have it not run like that in the beginning. I'm just going to make it suspend. And what this is going to do is going to basically fill that songs database with things from our other app. It's a very basic thing. And it's also going to see that Elasticsearch with song lyrics. I'm just going to show you that the Elasticsearch is running now. Cool. It's running. Sync jobs. Kube, CTR, apply, -f. I didn't create the Helm chart for this, but you can. It's only one file. Cool, so that job is created, and now I just need to quickly run it. Okay, so now the job is running. You can see that by going in here. Okay, now it's creating the job. Of course, normally you won't manually create it like I just did. It will run on the schedule. If you don't suspend it, that's not that. Just to show you that this thing is doing something. Okay, so it's running. So now when you go into that that song database, okay, this thing is a bug on this front end, but it now picks up some songs, and you could go in there and it will get all the data from where it gets it from, the service in the backend. Okay. Now here's the thing, right? So because I couldn't get the certificate working on this, on this cluster, I did spin up another one. So I'm going to swap over to a different cluster now and show you that works. But it's also good to see that in any case. CTR, okay. That's in a different zone. So I just want to quickly reset up this project. So G Cloud, and I'm going to initialize it to a different thing. Just that use the default region because the clusters are in different regions because I had a quota of 8 servers on each. Okay, quickly. Some of you have played around with GC2 before, right? But now most of you know that there's 3 months worth of like they give you $300 when you first sign up, and they let you use it for 3 months. But the problem is if you've registered like 2 years ago, you've used that free period up. So the trick is get your wife's email and register with your wife's account, and you'll get the $300 again. So that's what I did. So everything that you see here, the massive amounts of compute power that added to these things are all on my wife's account. Cool. I'm going to configure a default region. But let me just also, while I'm doing this, to show you in the cluster. So these are the clusters that I've spun up. I created one earlier just to test then this is the one that I've created now, and this is the one that that has everything running like as it should with a certificate, managed certificate, and with the domain name and everything. And I'll show you once I get in there. There's something really cool that I'd like to show you, and then I think I'll wrap up. But I just want to put this in here so that paste. The B mustn't be in there. Okay, sorry. Oops. Maybe the B must be in there. Okay, and then I just want to change it over to the right cluster. Cool. So now you'll see that it's actually pointing to some. This is the full deployment. All right. So just to show you, like in this one is if I show you the manifest, right? If I go into the gateway, you'll see this one has cluster IP. So the gateway isn't accessible in this cluster. What you can create is an ingress. So if you go into ingress here, and you'll see you can I've created a certificate, like a domain name outside of Kubernetes, like called DST demo. And then you can, there's a certificate file here, and all you do is include apply and manage certificate. That's wrong. And it will apply this, it will create a certificate for you. And then the ingress, you use GCP's annotations to tell it what certificate to use. So there it says manage certificate. I'm telling it allow HTTP because I've created front-end config. And this is very basic, but it tells you to, it will tell it to redirect to HTTPS. So if I go to the demo, and then you can see it redirected to HTTPS. And just to show you this, this is a different cluster. It's not the same data, but it still works. You can see it's a different person there, so that works. Okay, last thing that I'm going to show you. Hopefully none of you are sleeping. This one has a few extra things installed. So it's got Prometheus installed, and again, easily installed that with Helm charts. There wasn't much complex configuration. I think that's really amazing. And then I'm just going to install the services chart, and this is the services chart is this one here, and it basically just keeps a record of what songs you're seeing at what service, and you can build on these things, but it's just that's what it does now. So in here there's a deployment like we always have. There's a service, but there's this other thing called an HPA. And HPA stands for horizontal pod autoscaling. And back in the day when you configured autoscaling, it was, it was very complex. But yeah, I don't think it's complex anymore, right? Because in the other deployment files, you saw that I specified replica count, right? But there's nothing here. So what actually this HPA is going to do is going to specify a minimum replica count, which is in the values file, and it's set to 2, and the max to replicas is set to 3, right? So and then it tells it like some things that are not very important, like well, it's important when you're running production system, but for this demo it's not important. Don't scale up more than 1 pod per 50 seconds, and then also only look at the last 90 seconds to prevent what they call flapping. But anyway, we won't go into details. I'm going to install this chart with the Helm command. I'm sure you guys are thinking like, what is this guy? He's crazy. What is he doing? Where does he get all the time for this one? I'm in the wrong folder.
It's actually pretty cool, man. The one thing that newbies are often confronted with is the walls of YAML. It gets a lot easier once you understand what you're looking at. Trust us.
Okay, cool. So yeah, yeah, maybe this looks very confusing, but if you actually look at charts and play around with it, eventually it will be not that complex. So I'm gonna just quickly install this, and it will install the service, will install the deployment, and then the HPA, right? So we should see this thing eventually run, and then I will, probably just have 2 pods because there's no load on this thing at all. Oh, to be honest, I don't know why I installed this because it's already installed. I forgot that I'm not. I've gone to a cluster that's everything already. Okay, that's just the manual jobs that have failed, and that's fine. This is the services one, so it's actually spinning up a third one. Oh, it's rolling out. So what's going to happen is it's going to spin up 2 pods, and then it's going to terminate this ones that are there. So now I just want to show you basic horizontal pod autoscaling. And why is it called horizontal? Because you get vertical autoscaling. Vertical autoscaling is when you give it more memory, give a pod more memory, give a pod more CPU. But horizontal pod autoscaling is where you just give it more pods and you achieve the same thing. You should never do both at the same time because that won't work. So I've already installed Prometheus on here. I'm just going to quickly create the proxy, and don't worry about this. But it's installed and onto the cluster, and it's picking up metrics of all of the Kubernetes stuff that's running. So I need to just go to so some of you probably have seen Grafana before in terms of like your work metricing. And again, this isn't needed for a hobby app, but it's learning and stuff, and it was nice to learn about that. So okay, I don't know why it's taking so long. Oh, my internet is slow again. I was just studying my my German neighbor just messaged me at the start, saying that like his internet is slow. What do I use? And I told him, talk to Malti. He says, how does that work? And I told him, well, it always works. There's never been problems. And so now all of a sudden, that's now giving problems. Oh, but this can't be, what is going on here? Can you guys hear me, by the way?
Loud,
Yeah.
clear.
Yes, we can hear you. Well done, Rowan.
Yes, we can follow.
Maybe someone should come up with internet as a service.
Okay, yeah. Okay, let's do it a different way. So, right, I've created this little JMeter script, and it's very basic. All it does is logs in to sends the auth request to the authenticate endpoint, and then it will send another query to the services module, which is a little bit intensive because whenever you send this query, it determines the query is when last the other songs have been sung. So if I run it, yeah, so it's running now, and we're gonna increase the HPA max replica count, and then we're gonna see what we picked as. But let's actually I'll go a bit crazy here. Okay, it's already on 10, so that should be fine. So it's now sending requests at the moment 8.1 per. It's quite slow, but let's see. Hopefully my internet is a little bit better now. Okay. Looks a bit promising. Okay, Grafana is loading. My internet is slow again. Okay, maybe there's, okay, so this is come back with something, but maybe if there's any questions, then let me know. So you can see, yeah, maybe if there's any questions, then if this works later on, we can.
Okay, let's have a look at the question app, Vivox. The first question there, if it's from Zukisa, if a server goes down, the software can attempt to shift workloads to the other nodes, which can overload them too, and potentially bring everything down. What kind of monitoring tools and limits do you implement to avoid that?
Using you over there. Sorry, can you repeat that question?
Okay. If a server goes down, the software can attempt to shift workloads to the other nodes, which can overload them too, and potentially bring everything down. What kind of monitoring tools and limits do you implement to avoid that?
Yeah, that's a good, I mean, good question. So, like you can see in, so obviously in this scenario, it's just RB app, so the limits and stuff are not configured correctly. But at in a production setting, you would always have limits specified in your manifest file. So like I showed you, like in I can't remember where it was, but you will specify resource limits. In this case, there's a memory limit and there's a CPU limit, and Kubernetes will not schedule a pod onto a node if there isn't capacity available to provide, the requested amount. We then say, for example, if you use something like Prometheus, it will tell you when, when a node is over capacitated or whatever the word is. And you also get alerts saying that, like, for example, we have alerts set up that tells us if pod is failing to be scheduled onto node for whatever reason, or it's failing to start up, or that sort of things. Again, I'm not a DevOps engineer, so I don't know all the intricacies of setting up these, like, Prometheus and alerts and all of those sort of things. It just works. But yeah, it's very important that you're using this in a production setting, that you have your alerts set up, that you have your metricing, your logging. So, like the alt stack, for example, which you can, again, install with Helm charts. But, in a production setting, you'll have very specific config and those sort of things instead of just running the command like I did.
It's also not like the node will actually go down though, right? The pod will just go into an error status and hold. So only your pods die, so to speak.
Yeah.
Okay, should we do another question? Rowan? Can you hear me, Rowan?
Oh, yeah. Sorry, what is the question? Yeah.
I was saying, should I read another question?
Oh, yeah, you can.
Okay. Okay, the simple one. Do you need Docker to run Kubernetes?
No, I mean, you won't be running Kubernetes on your own machine. Dockers will be running in the Kubernetes cluster where you deploying your software to. If you were to use MiniCube, Docker would be on the actual virtual machine, so you don't need it. But I mean, you would probably want Docker for some reason, like on your machine, to do some dev testing and those sort of things.
Does that answer the question, Warren, or is the question that does it work with another kind of a container tool? Warren, did you leave?
Oh yes. I'm sorry. It can work with a different engine. To be honest, I actually don't know. Maybe Ross can answer that one. I'm not sure. Like, I've never. It can, but I've never I don't know, but I think there was talk about it moving over to something else.
Assuming you don't mind, just quick, you don't really need to only run Docker on Kubernetes. There's a whole bunch of different options. I think you covered them earlier, so cryo and a few other bits and pieces that are coming to the track. But you can actually run Docker, you can actually run Kubernetes within Docker, but that's a subject for another chat one day, I think.
Cool, thanks, guys. Another question, Rowan?
Yeah, go for it.
Okay. When should one not use Kubernetes? Just so, sorry, before you answer that, so I'm on this VVox and I'm reading them out from most liked questions, most to least liked. So please ask your questions. Please like questions that you like, and there are giveaways for the most liked question. So please get onto that app and do that. So the question again: when should one not use Kubernetes?
I can't really hear what you guys are saying. Sorry about this.
Okay. I'll also WhatsApp it to you. When should one not run Kubernetes?
Yeah, maybe post it in the chat.
Good question. Good
You
point.
should not run Kubernetes for a hobby app. And I don't think it's really for small scale deployments. Like scenario for like us at Declarative, 100%. We have got hundreds, if not thousands of services that are deployed into Kubernetes, and then we can really reap the power of it. And like in our team, we decomposing like a monolith. And when we need to spin up a service, we create a new repo. We include the Helm charts with it, and then we deploy that service into our Kubernetes cluster. There's no like approvals that you need, and we decide maybe with architecture from but decide that it becomes very cheap to spin up new services because it's very efficient. You don't need like hardware, you don't need a virtual machine, and you don't need an account and some cloud thing. That's all running in this Kubernetes cluster.
Okay, awesome. Thank you. Another question: what course or learning resources would you recommend to use to learn Kubernetes effectively? I'll post that in the chat. You heard it?
I use yeah, so I used like Udemy and well, initially a Pluralsight course way back, and then again a little bit on Udemy. But really, the most you're going to learn is just playing around with it. So use the free credits on GCP and spin up something. They won't charge you without your permission after 3 months. It's complete work. Your $300 runs out. So use that. I think that's spin up some some well-known applications and see how it goes.
Yeah, is your demo online? Is that something we could play around with? And
yeah, like I haven't put the charts on the repos yet. It's all on my local machine, but I can definitely do that. Yeah, I might just
that'll be great.
Use actually Kubernetes secrets for the passwords.
Thank you. Okay, what makes Kubernetes better than Docker Swarm?
To be honest, I think Docker Swarm is just like an older technology, and Kubernetes is more like accepted by the the tech industry and community. But I've never used it, so that's what makes it better. But I think it's just more features with Kubernetes as well, and you don't get like Docker Swarm on like AWS and GCP. I think you'd have to set it up yourself.
Okay, fantastic. Let's see, what is the difference between deploying applications on the hosts and containers?
Okay, so there's a lot of differences, but like say for example, if you have like a virtual machine running or like a server somewhere, right? You log in and now you set up your applications directly on there. You're gonna have to set up your environment variables. You're gonna have to copy the source onto the like the jar, and maybe back in the day you had like application servers and whatever, but things can get messy very quickly. And we had maybe another solution to that discussed with us last year with is it CDK and things like Ansible and Chef and those sort of things. But from an application perspective, like I think containerization is just the way to go. And you get other technologies that can also leverage containers like Beanstalks, ECS, and all of those sort of things as well. Yeah, I don't know if that answers your question. By the way, I don't have to be the only one answering questions on this. If anyone else knows a better answer to me, feel free to jump in.
Oh, you've opened a door, mate.
Yeah,
I love these questions. I have to say, I take part in a lot of tech things on this side of the world, and you guys put forward really high quality questions, and there's a lot of you. It's wonderful to see. Congrats on this community.
Thank you, Russ. Appreciate that. Thanks for coming. That's awesome. Great.
Yeah. No, I mean, containerization, just quickly, containerization is great because it's portable. If you've ever installed a Java app, you've got 25 different places you have to put files and check for logs and check for permissions. Where if it's in the container, you just spin the container up and everything's taken care of you, and it'll run on pretty much any architecture you can think of. And it's all done via one interface. There's one way of running a Docker container. So it's massively portable.
Thanks for that, Ross. That's awesome. Okay, so let's got serious questions about what were the benefits of using GCP rather than AWS?
So yeah, I personally liked AWS before because I was more familiar with that, but they didn't have the free. I just liked the $300 for 3 months on GCP. And is the question for me personally or for Declarative? Because we our GCP, our Kubernetes cluster in GCP, and I don't know the reasons for that, but for me personally, it just was the fact that it was easily available. And it's all very similar. You can take the same manifest and go and spin it up in AWS. And I've done that before with other things. It doesn't require much change, maybe a few minor tweaks here or there. With the annotations, those annotations provide like Google specific things, or AWS provide their own annotations that you can provide. Yeah.
Okay, awesome. How long did it take you to learn Kubernetes?
I don't know the answer to that one because I did a course and never really used it much at my old job, and then at my new job at Declarative, we write our charts as part of our repos, our Helm charts, and it's not complex. But again, we don't manage the Kubernetes cluster itself. We have a DevOps team that does that, and as developers, we just write the Helm charts that will actually, that specs your application and the scaling and the that sort of thing, services and so forth.
Okay, is there a way to tell Kubernetes to start up containers in a certain order? For example, start DB container first before web container. Okay, just to be clear, you won't be starting up containers, you'll be starting up pods. And those pods have the containers that we're talking about. You will do it, you will apply the manifest in the order that you need. You won't have one script that does everything. That's at least how we do it. I'm not sure if there's a way to only spin up a pod if another service is available. By the way, there's something that I didn't really show, and this is very important actually from a developer's perspective. Kubernetes has this concept of readiness endpoints and liveness probes. So what we would do is every service would have a ready endpoint. In the deployment file, you'll specify what that endpoint is, so in your application, and then Kubernetes itself will, when it brings up a pod, it will query that readiness endpoint
and that readiness endpoint will return a 200 OK saying this thing is ready. So what you normally put in there is a query to like your database, your downstreams, we call it. So you will query like your database, you'll query all this other services, readiness endpoints, like or liveness endpoints from there. And once all of that returns OK, your thing will then return OK to Kubernetes, and only at that point will Kubernetes route traffic over to that pod because it's in a ready state.
Would you mind if I jumped in there quick?
Yeah, go for it.
Go for it.
So usually I've had this question a couple of times myself. Usually when you have a pod order dependency, it kind of, from a conceptual and architectural point of view, breaks the concept of microservices. You should never have sort of a codependent service. Having said that, like, never mind the big architectural hat that I'll push to the side. There is a way to do it. It's a very ugly hack, but each container, when it starts up, can have what they call an init container. So it's a little container that sits there and basically does something. And once it's finished, then the main container can come up. And you can actually, using the SVCs or even pod direct references, you can tell the init container to check for other containers. And that's one way of ensuring order. But please don't do it. It's a bad idea.
Thanks for that, Ross. I think everyone's going to try that out now. Okay, Rowan, we were about out of time, so that's Q&A. Just post it in the chat. You can continue to post any questions in Slack, and I'm sure Rowan and Ross and a bunch of other guys who aren't even at the meeting but are in the community will answer. You can crowdsource the best answers. I'm always telling people at work that message me privately. I said, just message publicly and we'll crowdsource an even better answer. So go ahead and do that. Rowan, is there anything else you'd like to show us?
No, I mean, I just, the charts are working. This is pulling data from Prometheus. And yeah, I don't know if you can still see my screen, but it's scaled up to 3, and there's just a few settings probably that needs to be fixed to get that to go further up. But anyway, thank you. That's all. Thank you guys again for the opportunity to present.